Welcome back. This is the lesson number 4, Encrypt and decrypt. Let's open this file. It's an empty file. This lesson is very important because it is a small exercise from the real ransomware. Because most function and encryption module used in this lesson is used in the real ransomware, and it combine all the ideas we have studied in this unit and put it in one lesson. So let's start. First, we will import the required library from crypto.fernet. As we know, we will import the fernet module, and also we will import the time module and import the OS module. Okay. Let's print the encryption key. Here we will use this key for the fernet. Let's create the encryption function. Def, and the name of the function I will call it encrypt. This function will take one parameter, which is the file path. Okay. Let's open the original file. Open the original file. How to open any file with open function. Take the path of the file, close this. You will take this parameter, which will path to the function, and the mode of opening here is encrypting the file, so we wanted to read the file, and we will read it as binary, as we mentioned before, as if dot read, and put this data in a variable called original. It's out from the function open, and here we will create a variable called part1. In this variable I will start the first 16 character from this data that will read from the file. The data read from the file is stored in a variable called original. Okay, I will store in part 1 the first 16 characters. After this, I will create a variable also called part2. In this variable, I will store the remaining data from the 16 to the end of the file. Okay? Let's print part1. And print part2 to see the result. Here I have the encryption function. Here I put a folder files to exercise on, so we can train on this file. Let's take the boss of the folder containing this file, r single quotation, and the boss here, slash. Let's take the text file and train on. I will run. Here you will notice, let's open this text file and see. Here you will notice that part 1 and part 2 is bytes data, which means this data is typed as byte because it start with B and single quotation around the text. Part 1 contains the first 16 character, and part 2 contains the remaining of the data in the file. Here, the first 16 character until this space, and the remaining of the data, as we mentioned here, is put in part 2. Okay. Let's delete this and complete the code. We want to encrypt part 1, the smallest part of the data. Encrypt part 1. We will create a variable called encrypted data. In this variable we will call the Fernet module and pass the key of the encryption to this Fernet. Dot, we will use the encrypt function from the Fernet module. In the previous ransomware, in this unit, let's see, here we use function encrypt at time, and this function needs the text you want to encrypt and the time of the encryption. But in this lesson we will use the function encrypt, and this function take one parameter only, the text you want to encrypt encoded as byte, which means start with B. And because the text here is start with B character, so we don't need to encode it. So I will pause here part 1, the part I wanted to encrypt. Okay. Let's print encrypt data and see the result. Here you will notice that part 1 is encrypted. Let's delete this print and complete. I will open the file. When the file in write mode. In this open, I open the original file in read mode and read data from this file. Here I will open it in write mode. So I will type here the open function and it will take the path of the file path, and the mode of the opening process, which is write as binary. We can write only with text only, but I type here write and read as byte to make this process for any type of file, because we will encrypt for an MBC and text and so on. So I type write as binary for all type of files. As if, okay, and here I will type if dot write look and focus on what I will write here. I will type in the text here. You will notice that our text file here contain the data before the encryption process. All this data, you can understand these words because those words are English and there is no word encrypted. But after the encryption process, you will notice the difference. I will type in the file the encrypted data that I have been encrypted here, plus the part 2 of the file. Okay? Because I open the file and for read and open it for write in the same function, I should type here if.close to make the read and write save operation. Let's run and see the result. Let's look at the file. Here you will notice that the first part, which is part 1 of the file, which is the encrypted part, is written on the file. So here I have the first 16 character as encrypted form written in the file here, and the remainder of the file not encrypted, because the encryption of whole the file or all data in the file will take more time, so I only encrypt part of the file and write the data encrypted and the original remain data on the file. Okay. I also can let's see the decryption function. It's important. Decryption function. I will create a function called decrypt. See there? Okay. Decrypt. I will pass to this function the path of the file as parameter. Okay. To decrypt the file, first you should open the file to decrypt the part you have encrypted only from the file and write this part after decrypting it by its original type with the remain data on the file, so the file can return to the first shape to it. So let's type here the comment, open the file for read. So I will type with open, and I will pass here the path of the file, and the mode I will read the file as binary. Here the decrypted data, which is f dot read. Okay. I will divide the file also to two parts. Part 1 and part 2. In part 1, I will store the encrypted part of the file. Let's see the file. This is the encrypted part of the file. If we wanted to see the length of this file, let's hash this function and type here print len and single quotation and copy and paste this encrypted part here. Let's run and see the result. Okay, let's comment to those two lines also. And print. You will notice that the length of this encrypted part is 120 letters. So I will divide our file to two parts. The first part is 120 letters, and the second part is the remain of the file after 120 letters to the end. So I will type here decrypt data and let's eliminate those hashes. Here I will take it from the start of the file to 120 to the letter ordered 120. And in the second part I will take it from 120 to the end of the file. Okay. Let's close our file. And eliminate this print and complete our decryption mission. Okay. I will open I will decrypt part 1. So let's decrypt the encrypted data in part 1. Now I will type here decrypted data 1 to distinguish it from decrypted data here. To distinguish between decrypted data, and here I will type decrypted data 1. And decrypted data 1 I will call the Fernet module and pass it our key dot decrypt function, and it takes the encrypted data, which is part 1. Okay. I will open the file to write on decrypted data. Let's see this decrypted data before we do anything. Print decrypted data, and let's replace unit hash and replace this by decrypt. Let's see the result. Here you will notice that those are the first 16 letters from the file that we have read before, the encryption process. We have read before the encryption process. Let's write this part after decrypting it and the remain data on the same file, so the file can return to its original form. To write on the file, I will use with open, pass it to the file pass, and the mode, which is write as binary, alias if dot write. I will write the decrypted 1 plus part 2, this part 2 of the file, let's run this function here to make this process. We should here if dot close. Let's run. Before run, let's see the file again. Here is the first 16 character encrypted as 120 letters. After let's close this file and see and decrypt this data and write it on the file and see the result. Run. Let's see the file again. Here you will notice that those encrypted data return to their original form, as you see. Okay. You can also do the same operation for folder, not only on file. How you can do this? By using the walk function. So let's use the walk function. and get this function from the previous lesson. Let's go here and get hook function from lesson 1. This is the function. Let's print it here and do some modification on this function. As we mentioned before, those are the extension we wanted to encrypt only. So if your file have another extension, they won't encrypt it. Only the extension included in this list will encrypt, and the other extension won't encrypt. Okay. Here I do for and work on all the folder and get files on this folder and put them in variable f. I will loop through each file name in this folder, which is represented by list. For each file, I will get the full path of this file on full path variable by combining the main directory, which is the directory of the folder containing this file, and the name of the file including extension. Here I have the extension of the file, which is split the full path of the file from the dot letter. So after the split operation, I will get the full path of the file as the first item of the list, EX, and the second part, which is the extension, is item 2. I will type here -1 to get the extension, which is item 2. Here you will find an error, so you should create a list to store only the path of files that have those extensions. So you should type array1. Okay. To loop through files in a specific folder, you should type for. But I will put this for in the main. And I will do here a for to loop through each item in array1. And in each loop I will this function will I will call the encryption function first. So let's here put the encryption function and pass to it only the paths of the files included in this array, which is the files that have this extension. To do this, I should call the walk function for the encryption process to make this function fill array 1 with data. And this function, walk function, take the name of the folder or the path of the folder containing the data. So I want to try to on this folder. So I will put here the path of the folder to try on. Let's run this function and see the result. There is some error. Let's see what the error for. I'm sorry. Those are encrypt, not decrypt. This one. Okay, the encryption process has been finished. Let's open this file. You will notice that the first 16 character has been encrypted, and also in this SRT the first 16 character has been encrypted. Let's open this. The first 16 character of the file has been encrypted, and also in video you will notice that the video can't open because the first 16 character has been encrypted. Okay. To decrypt this data again and make video open, just type here decrypt and run. Let's open this video again. As you see, our video open normal as we expect. By this, we have reached to the end of the lesson. See you in the next lessons. Welcome back.